Determine the equation of the normal to the circle at the point 5, 6. Let us begin. So here we have a circle centered at C, and we have a line which is tangent to the circle, let's say at the point A, having the coordinate 5, 6. Our goal will be to find out the equation of the normal through the point 5, 6. So this is going to be the normal line. So here we will start with the given equation of the circle. We have x squared plus y squared minus 5x plus 2y minus 48 equals to 0. What we'll do, we will compare it with the general equation of a circle, which is x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. On comparison, we find that 2g will be equals to negative 5. The value of 2f will be equals to positive 2, and the value of c will be equals to negative 48. So g comes out to be equals to negative 5 over 2. F will be equals to 1 and c stays as negative 48. The reason why we're trying to find out the value of g, f and c first, because using these three constant values, we can find out the equation of the tangent line by using the point form. So let's quickly recap the point form. The point form states that if we have a line which is tangent to the circle at a point, let's say x1, y1, then the equation of the tangent line will be given by x times x1 plus y times y1 plus g multiplied to x plus x1 plus f multiplied to y plus y1 plus c equals to 0. So here we have the value of g, f and c. We also have the value x1, y1. Now x1, y1 is nothing but the coordinates of the point A. Okay, so we have x1 corresponding to 5, so we're going to get 5x added to 6y, g value, so that's negative 5 over 2 multiplied to x plus x1, so x1 will be positive 5. Then we have f value, so that's 1 will be multiplied to y plus y1 is going to be 6 plus the constant c, so that's negative 48. So this will be equals to 0. So when we rearrange the terms, we're going to get the equation of the tangent line 5x plus 14y minus 109 equals to 0. So this is going to be the equation of the tangent line. So let's try to figure out the slope of the tangent line. So here, to find out the slope of the tangent line, we're going to rewrite this equation in the slope-intercept form, which is y equals to mx plus c. So m is going to be the slope. So we have 14y equals to negative 5x plus 109. So y will be equals to negative 5 over 14 times x plus 109 over 14. So here we have the value of slope m equals to negative 5 over 14. Now that we have this is going to be the slope of the tangent line. Now that we have the slope of the tangent line, we can also find out the slope of the normal line, because a normal line is nothing but the one that is perpendicular to the tangent line, and by the properties of straight lines, we know that whenever two lines are perpendicular to each other, then their slope, product of their slope will be negative 1, which means m1 will be equals to negative 1 over m, which gives us the value positive 14 over 5. And we have the normal line passing through the point 5, 6. So we can find out the equation using the point slope form, which is given by y minus y1 equals to the slope m times x minus x1. Now in our case, m will be nothing but m1. This is so let's find out the equation of the normal line. Through the point 5, 6, so we're going to get y minus y1, so y1 will be 6 equals to the slope, which is 14 over 5 multiplied to x minus x1, so x1 will be 5. Let's multiply throughout with 5 to get 5y minus 30, and we have 14 multiplied to x minus 5, so we have 14x minus 70. So we get 14x minus 5y minus 40 equals to 0, and this is going to be the equation of the normal to the circle at the point A having coordinates 5, 6.